Good morning, everyone. In the last session, we discussed about the important concept called collection framework. So, under this particular collection framework, we discussed about the collection interface or common methods as well as the interface specific method we discussed here. So, the specific method we identified each and every method internally. It is expecting the index because list interface it is going to be implemented based on this particular index roles here. Okay, so this is we need to understand regarding this particular interface here. So list interface. So what about the second interface we identified here? Set interface. Okay, set interface. So let me write the name of the interface here so we can easily understand here. So this is a set interface we are having. So this is also internally it is expecting the generic type here, and internally this particular set is extending from this particular set it is going to be extends from the collection. Okay, so yesterday I already discussed here collection is the super interface for all the collection framework. So at the same time, now if you remember list also, okay, list also internally it extends from the same collection. Internally it is extending from the same collection. So at the same time set also internally it is extending from the same collection. Now any specific method do we have regarding this particular set interface, so that we need to understand. So yesterday we discussed about the purpose of this particular list interface. The what is the purpose of this particular list interface here? The list interface basically it will work with the duplicate objects here. Okay, the first one is it will work with the duplicate object, and so it will try to work with the positions like index. So based on the indexes only, it will update or load the data. Okay, so it will update or the load the data, and so insertion order. Insertion order. It is important here. Insertion order. So what exactly it will do? Insertion order means so whenever we are trying to insert the order, the same data like the same order, we are going to be get the data. So insertion order or the loading the order will be the same here. Like what the way we are trying to insert here, the same way we are going to be get here. So these are the main points we need to understand regarding this particular list interface here. Okay, and at the same time now we need to discuss about the set interface. So set basically, so as I suggested internally it is extend from the collection interface here, and it is not going to be provide the duplicate elements. Okay, it is not going to be provide the duplicate elements here. So the set interface mainly it will work on the unique elements. So whereas the list interface it will work on the duplicates also. Okay, whereas a list interface it will work on the duplicates, but whereas set interface it is not going to be work with the duplicate elements. And here the insertion order, whatever the insertion order we are going to be get, we are not going to be get the same order. Okay, because internally what exactly it will do this particular set interface? The set interface basically it will work with the important method called equivalent hash code. So based on this particular equivalent hash code method, so what exactly it will do? It will try to change the position of this particular insertion order. Okay. So this is what we need to understand here. So we'll see how this particular set interface internally it is implemented. Now, so the list and set will work on the opposite order. The set and list it will work on the opposite here. So now let me provide the set interface. So this is the set interface. Okay, now here you can see. So set internally, it is extending from this particular collection. Set internally, it is extending from this particular collection. So now we observe here. So I need to drag to the right side here so that we can easily understand here. So what exactly the set related information we are going to be have here. Okay, so this is a set. Now at the same time, this is the list so that we can easily understand what are the specific method we are having in the list and what are the common method we are having under this particular collection interface. Now come back to this particular set here. Observe carefully int size. So int size is coming from the where? If you go to this particular collection interface here, so here you can see int size. The same int size we have under this particular set interface. So it is a common method. Now at the same time is empty. At the same time is empty. And here the second one, like a third method, contains method. So iterate method. Okay, so to array method. Now, so this is the generic type related to array method. Add method. So it is pointing to the same add method. And remove method. Okay, contains all. So these are the add all methods. As of now, whatever the method we have observed here, all the methods are available from this particular collection interface. Now here you can see retain all. Okay, retain all method. So remove all method, clear method. Okay, so retain all, remove all, add all, clear method, everything. So which is coming from the collection interface. So clear method, equals method, hash code method. So now these are the default methods. Okay, these are the default method. It's something like a split iterator. We'll work on this particular default method. So later we'll try to discuss about this particular default method. So this is the only one the specific method we are having, split iterator. Along with this, now we have a set of method. Okay, so this is a set of method here. So we'll see these are the specific method. One is a off method. So second one is a split iterator. Any specific method do we have here? So now you can see these are the off overloaded method. So which is expecting different type of parameters. So these are the off method we are having. So this is also off method we are having here. Now here you can see the last method we are having copy. The copy of method basically what exactly it is doing. Here you can see it is expecting the parameter. It is the generic type bounded type parameter we are having it. Now what we are doing it. So whatever the collection we are going to provide. Okay, whatever the collection we are going to be provide. Now we are checking it. If the collection is instance of this particular abstract immutable set here, we are returning the set here. So otherwise we are calling the set of new hash set. Okay, new hash set we are calling, and internally we are calling to array. It will try to return this particular set type here. Okay, so we'll see this particular copy of what exactly it is doing. So basically it will try to return the unmodifiable set here. Unmodifiable set means, so once the set is created, we are not going to be modify this particular set here. So these are the three methods we are going to be discussing. These are the three methods we are going to be discussed when we are trying to work with this particular set here. So set basically, if you observe, set does not contain any specific method. Whatever the common method we have observed under this particular collection, the same collection related methods we are going to be access here. The same collection related methods we are going to be access into this particular set interface here. Okay, so these are about the important section regarding this particular collection here. Regarding this particular set interface here. So we observe the set and list. Basically, it is going to be work on the opposite way because set will not allow the duplicate, whereas a list interface will allow the duplicate. And so the set basically, whatever the position we are going to provide, in the same position we cannot get it here because internally it will work with the equivalent hash code. So based on the hash code, it will go and insert into the respective index locations. Okay, so we'll see how the set internally it is going to be implemented. So far, what is the diagram we identified here? The diagram, if you remember, so this is the collection. Okay, so now here we observe the list interface and we observe the set interface, and both interfaces are internally extending from this particular collection interface here. Okay, now we need to discuss the another important interface here. Another important interface. So if we observe, before going to discuss about the another important interface here, the set internally, it is extended by the another important interface called sorted set. Okay, sorted set. So here you can see, so list does not contain any specific the inner, like it's like the nested interfaces here, but the set can contain the something like nested related interfaces here. The one we are going to be discussing here, sorted set here. So observe the sorted set how it is implemented, because the set does not contain any specific method. So these are the three default method, default and static method we are having here, but there is no abstract method. There is no specific abstract method. All are coming from the collection interface. So now we need to discuss about the sorted set. Okay, so this is a sorted set we are having here. Now, so what exactly the sorted set is doing now? What exactly the sorted set is doing now? So here you can see, so this is a interface called sorted set. Internally, it is extending from the set interface. Okay, internally, it is extending from this particular set interface here. So what do we need to understand this particular sorted set behavior? So what exactly the sorted set will do? So basically, the sorted set, it is going to do the ascending or descending order. Okay. So based on the some ascending or descending order, the sorted set, it is going to be implemented here. So this is the main purpose of this particular sorted set here. This is the main purpose of this particular sorted set. So what exactly we can understand here? What exactly we can understand regarding this particular interface here? The main important method called comparator. So using the comparator, we can make the values in the like ascending order or descending order here. Okay, so this is one of the important method called comparator. So we'll see how this particular comparator is implemented internally. How this particular comparator. To understand this comparator, now we need to understand the comparator interface here. Okay, so when we're trying to work with this particular comparator method, we'll see so what exactly the comparator will do. So comparator basically, it is one of the functional interface. Okay, whenever we are trying to work with the functional interface, what we need to understand here, the functional interface can contain only one abstract method. One abstract method here. So here you can see, so this is the compare method, and internally it is expecting the two parameter, and with the two parameter also we are having generic type. The two parameters also having generic type here. Getting the point? So this is very important information we need to understand here regarding this particular comparator here. And another important section basically, so here you can see like equals method and reverse method. Okay, and then comparing. So these are the default methods, but only one abstract method we are having. So what is that? Compare. What is that we are having? Compare method here. Okay, this is what we need to understand regarding this particular interface called sorted set here. Now go back to the next method. So next method, subset. So it is a common word. So subset basically what it will do, based on the from element and to element. Now we are going to be creating now we, now we are going to create the sorted set basically based on the from element and to element, we'll create a sorted set object and it will return the between the elements here. So this is we already discussed when we are trying to work with the list here, sub list here. So what exactly it will do this particular sub list here? From index and to index. Between the elements, whatever the element we are going to have, all the elements are copied with a new list object. At the same time here, between this particular from element and to element here, we are going to get the sum of the elements. So that will try to create a sorted set object and will store into the sorted set here. So this is the main purpose here. Okay, so now the next method, headset. So these are the important method, headset. So headset and tailset related methods. Now what exactly the headset method will do now? What exactly the headset method will do now? So here you can see, so what is saying this particular headset here? Here you can return a view of the portion of this particular set here. Okay, and here, so strictly less than the given element. Getting the point? Basically here what we are checking is less than this particular two element, whatever the element we are providing, so less than to this particular element, all the elements are going to be written. Okay, all the elements are going to be written here. So this is very important, we need to understand here. So these are the headset method, less than or less than equals to now two element, less than two element. So whenever this particular up to this particular condition, how many elements are going to be satisfied, so those elements are going to be written. Getting the point? Let's say, so we are having 10 elements, we are having 10 elements, so I'm giving up to 5. Now I'm giving less than to 50. Okay, so now here you can see this 60, it is not a less than to 50, so these are the values are going to be written here. These are the values are going to be written here, and from here these values are not going to be written. So basically it's a simple understanding here. So less than to this particular given parameter, how many elements are going to be satisfied here, so those elements are going to be written by this particular sorted set here, this particular sorted set here. Now the next method, tail set. So carefully observe what exactly the tail set is doing now. What exactly tail set? So here you can see the tail set here. Now here greater than or equals to the from element. Greater than or equals to. So what we can understand is this is the condition. Okay, this is the condition. So is that the greater than or the from element? It should be matched here. Okay, so the above etc. simply we use the less than condition. So this is only the differences between etc. and tail set here. Now, so another important method basically here, first method. If I want to load the first element here, we can call this particular first method, and at the same time, if we want to load the last element, if we want to load the last element here, so what we will do, we'll call this particular last here. So this is the default method. Okay, so this is the default method we'll understand here. Now another important section basically, so tail set what I'm doing, greater than or equals to, I'm trying to write a condition so that we can easily understand whenever we are trying to review this particular document here. And here less than, and here less than condition. So this is what we need to understand regarding this particular headset and tail set methods. Okay, so it's a simple method. So basically whenever we want to load the less than values, we can go for the headset method. When we want to load the greater than values, we can go for the tail set method. Okay, these are the two additional method we are having, and along with this, so one we observe the comparator, and the second one is subset. Subset is a between the characters are between the set of objects are going to be loaded, and it will create the sorted set object here. Okay, it's a simple one. And the second, the first and the last method basically, if you want to load the first element, it will load the first element and it will load the last element. So this is the sorted set methods here. And another important another important interface we are going to have under this particular set interface. So that is called navigable set here. Okay, so this is also important interface here, navigable set. So if you remember, the first top level interface is set, and the second one is sorted set here, and the third one is navigable set here. Navigable set here. Okay, so this is what we need to understand here. Now this navigable set internally, it is extending from this particular sorted set, and the sorted set internally, it is extending from the set here, and the set internally extending from the collection interface. So now see the hierarchy. So how this particular hierarchy is implemented here. Now the collection related methods, the collection related method, still we can access into navigable set, sorted set, as well as set interface here, because internally, so this is the sub interface basically. So this is a super interface, collection is a super interface, and navigable set is a sub interface, and these two are the intermediate. Okay, these are the intermediate related interfaces we are having. If you remember the multi-level hierarchy, if you remember the multi-level hierarchy, you can understand here. So what exactly this particular piece of codes are implemented here. Okay, so now what exactly we need to understand here. So this is the hierarchy. First we need to understand from the collection, it is extended to set. From the set, it is extended to sorted set. From the sorted set, it is extended to the navigable set here. Okay, so now we'll identify the what exactly the navigable set will do here. Okay, so this navigable set basically, it will try to provide the retrieval operations. Retrieval operations. So based on the closest match, based on the particular condition which is going to be supported here. So based on the particular closest match here, it will try to return the values here. Now let me show you the navigable set how it is implemented here. Okay, so this is a navigable set we are having here. Now I'm trying to copy into this particular navigable set here. Now here you can see public interface navigable set, and which is extending from this particular sorted set here. So let me add the same information here. Okay, public navigable set, so which is extending from this particular sorted set here, which is extending from this particular sorted set. So now what is a specific method? Lower method. If you remember, so this method first time we are trying to see here lower method. So as of now, this method we did not identify from this particular top level to bottom here. From top level to bottom here. Getting the point? Now here you can see what we can understand basically here. So this is a lower method. Okay, so what exactly the lower method will do now? Now here you can read this, return the greatest element in this particular navigable set here. Okay, and here and so what is the condition we are checking here? It will return the greatest element, but here so strictly we are checking the condition. So strictly less than the given element or null if there is no such element. So what we are understanding basically, it will return the greatest element. Okay, greatest element less than to this particular given if the parameter, whatever the parameter we are going to be provided, and null we are going to be written if there is no such element, the such condition is not satisfied here. So what you are understanding is, it's a simple understand here. Here we are trying to check the condition call less than. Here we are trying to check the condition call less than. But if you remember, this headset also, it's trying to return the same information. Okay, headset also, we are trying to work with the same condition, less than condition. But here, what you need to understand here, what you need to understand basically, so you need to understand the important section call. So basically here, the less than, okay, so both methods are going to be used the less than, but one method will throw an exception. One method simply return null. This lower method simply return null. This lower method simply return null here. So whereas the headset method will throw an exception. Okay, now we'll see this. Now I am under the headset method. So here you can see, here you can read this important the condition. The return set will throw an illegal argument exception when an attempt to insert an element outside of the range. Okay, so basically this particular etc will throw an exception whenever the particular condition will not satisfy, but whereas this particular lower method, simply it will return the null. Simply it will return the null, but either condition will be the same. Condition will be the same, the less than condition. So this is what we need to understand, the lower method and etc method differences here. So here floor method. So what exactly the floor method will do now? What exactly? Floor method. So here you can see floor, basically it is trying to return the greatest element and less than or equals to the given element. Okay, so lower method simply it will work with the less than. So whereas the floor method it will work with less than or equals to. So this is the differences here. So what about the ceiling method? Okay, what about this particular ceiling method? Now what we can understand here, here you can see the simple condition. So greater than or equals to the given element. Greater than or equals to the given element here. Now what you understand here, here we can write the, so greater than or equals to. Okay, so the ceiling, now it is satisfied with this particular tail set, because here also we provided the same condition, greater than or equals to, and here also we are providing same. But what is the difference here? Simply, okay, so simply it will return the null value whenever the respective condition is not satisfied here. But whereas this particular sorted set here, the tail set will throw an exception. The tail set will throw an exception here. So this is what we need to understand regarding this particular head set and tail set here. But now go to the navigable set here. What we are doing here, so the lower method will return the greater value based on the less than condition, and the floor, so again it will work with the less than or equals to condition here, and the ceiling it will work with the greater than or equals to, but it is not going to be through any exception. Simply it will try to return this particular null if the any condition is not satisfied here. Now the another method, so another method we are having higher method. So what exactly it is doing here? Okay, what exactly it is doing? So simply this particular higher method, it will work on the greater condition. The higher method it will work on the greater condition. So this is important here. The lower method will work on the less than, and the floor method will work on the less than or equals to, and at the same time The ceiling method will work on the greater than or equals to, and the higher method, it will work on the greater than here. Okay, so this is what we need to understand regarding this particular 4 methods here. So now you can understand the below methods. So what exactly the below methods are doing now? So here you can see pool past. Okay, so pool past, the name of the method itself is suggesting, it will try to return as a first element. It will try to return as a first element. But here you can see retrieve and remove the first element. Can you retrieve and remove the first element from this particular navigable set here? So if the element is not there, it will simply return the null. If the navigable set is an empty, it will try to return as a null here. So this is what we need to understand here. Now what I'm doing here, so I'm going to be copy this message so that we can easily understand it. So what exactly the pool past method will do now? What exactly the pool past method will do now? So same at the same time pool last here. At the same time pool last. So what exactly it will do? It will try to remove the highest element. It will try to remove the highest element. So whereas here the lowest element is removed from the pool past method, and the pool last method basically it will try to remove the highest one. And iterator. So this iterator we already identified, which is coming from the collection interface. And here you can see, so descending set. Descending set. Now what exactly the descending set method will do now? So here you can read the message. So the purpose of this particular descending set, what is doing is returns the reverse order. Okay, it is going to be returns the reverse order view of the elements that contain the set here. Okay, so simply we can understand it will try to return in the reverse order. Simply we can understand it will try to return the reverse order. So we'll see how it is going to be return the reverse order. How it is going to be return the reverse order. Okay, so now iterator, descending iterator. So this is, you can see, this is basically navigable set it is returning, and this is returning iterator. But so here both will do the same. Both will do the same here. Returns an iterator over the elements of the set, and in descending order. Basically, this value we are going to be getting the same descending order, but only the return type here. So first one will get as a navigable set. The second one will get as a iterator. The second one will get as a iterator. So this is what we need to understand regarding this particular return orders here. Sorry, descending order. Now subset. So subset we already identified when we are trying to review the sorted set related methods here. But what we can understand here, so subset from element and to element. Okay, from element and to element. So here, so Boolean two conditions we are having, from inclusion and to inclusion. If you remember, here also we are having the same subset method, but here it is expecting only two parameters, from element as well as to element. Okay, from elements and to elements here. Now from elements and to elements. So another important the concept basically what we need to understand here. So additionally two parameters we are having under the navigable set here. So what exactly these parameters will do now? Here you can see the from inclusive. This is the Boolean parameter. So what is saying here? If you provide the true, if you provide the true, and what is saying here? If the low endpoint is to be included, if the low endpoint to be included in the return view. Getting the point? So basically what is saying here, the low endpoint is included in the return view, and at the same time if you provide the to include, the high endpoint is included in the return view. Like lower value and higher value also it is going to be included when you are providing true. Otherwise, this lower and higher values are not included. Okay, so we'll see this particular condition. Basically, whenever we are having this particular Boolean related parameter, so some of the parameters are going to be included and otherwise it will not included the respective parameters here. Okay, so we'll see this particular implementation. So how exactly the subset internal it is implemented based on this particular 4 parameters. So now you can see add set method. And if you remember in the sorted, like in the sorted set also we are having add set method which is expecting one parameter, 2 element. But here you can see along with the 2 element, now we are having Boolean inclusive. So here you can see the same condition. So when we are providing the true value, it will include the high value, otherwise it will not include the. Okay, so this is what we need to understand here, the navigable set here. Okay, so this method also will review when we are trying to review the navigable set related information here. So first we need to understand the important methods here. Okay, the important methods and purpose of this particular interface here. So then we can easily understand the implementation of this particular each and every method. So add set method we observe, and at the same time we will understand the tail set. So tail set also will do the same. Here you can see condition less than condition greater than or equals to condition. So same conditions we are going to be used here also, but only additional parameter we are passing, that is called Boolean inclusive. Okay, and so one more subset here. So one more subset here, so which is copy from this particular method. Okay, so here you can see sorted set is returning, subset is the name of the method which is expecting the 2 parameters. So same method. Now, so add set method. So this is an add set method. Okay, and tail set method. So this is a tail set method. So what you understand is these 3 methods it is added into the navigable set. Okay, so if you add or if you are not adding, basically what happens here, internally the navigable set internally extending from this particular sorted set. So the sorted set methods are going to be available into the navigable set here because of this particular inheritance. If you remember the inheritance concepts here, so now we can easily understand here. So understand here how much the particular inheritance concept is important here. When we are trying to work with this particular collection, the inheritance are going to be play very important role. So why it is going to be play very important role? Basically, here we are trying to work with the multiple values here. Getting the point? Here we are trying to work with the multiple values. So whenever we are trying to work with the multiple values, so some of the values we are keeping in the super interface, and some of them are keeping into the sub interface here. So this is what we need to understand regarding this particular navigable set here. Okay, so far what are the interfaces we discuss here? So we discuss about the set interface and sorted set we discuss here, and navigable set also we discuss here. Okay, so these are the 3 important interfaces we discuss here. Getting the point? These are the 3 important interfaces we discuss here. Okay, so any questions? So regarding this particular the 3 interface, any method you want to explain one more time? Okay, so if we don't have anything, now what we will understand basically here, we'll understand the another important interface basically. So whatever we discuss here, queue. Okay, now so before discussing about this particular queue, now we'll understand the hierarchy. Okay, collection, list, set, queue. And here, so what we can understand the sorted set, navigable set. Okay, so this is the hierarchy. Now you can see, so list internally extending from the collection, set internally extending from the collection. So queue also will extend from this particular collection, and sorted set internally extending from the set here, and navigable set internally extending from this particular sorted set. So far, this is the hierarchy we discuss here. Now we'll move on to the queue here. So what exactly the queue will do now? Basically, the queue interface will provide the first in first out behavior. Okay, the queue basically it will provide the first in first out behavior. So now we'll see so what exactly the queue interface is doing, and what are the specific method we are having regarding this particular queue here. What are the specific method we are having regarding this particular queue? Okay, so let me open this particular queue interface here. In place of this particular navigable set here, I'm trying to open this particular queue. Okay, so this is the queue. Now I'm trying to drag into the right side so that we can easily compare this particular queue. Now you can see public interface queue and extending from this particular collection. So this is also I'm going to be add this particular specific methods here. Okay, so compared to the sorted set, navigable set will contain the more method because it will do the some of the overloaded methods here. It will do the some of the overloaded methods here. So this is what we need to understand regarding this particular queue here. Now observe carefully public add method. The add method we already identified, which is coming from the which interface here? Collection interface here. Okay, so now here you can see offer method. Offer method. So what exactly this offer method is doing now? This is the specific method we are having. This method basically provided into the, it is not available into this particular uh, collection interface. It is a specific method we are having under this particular queue interface. Okay. So now what exactly it is doing this particular offer method? What exactly this particular method is doing? So here you can see, so insert the specified element into this particular queue. Offer method also it will insert the value into this particular queue, but here what we are doing here, so if it is possible to do immediately without violating the capacity restrictions. Okay, without violating the capacity restriction. So what you are understanding here, without checking this particular capacity, okay, without checking this particular capacity, now it is going to be added the particular value into this particular queue. Okay, so whenever we are using this particular capacity restricted queue, this method generally preferable to add. Getting the point? When we are trying to work with the capacity restriction, this method, the offer method, basically what is doing it is not going to be check the capacity related information. So directly it is going to be added. Directly it is going to be added this particular method. The elements are going to be added into this particular queue here. So this is what we need to understand regarding this particular offer here. Now here you can see what exactly it will return here. True if the method were added to the queue, else false here. So whatever the element we are providing, if this particular element added successfully, will get the true. So otherwise we'll get the false. Okay. So this is a important method. Basically, the add method we are having boolean, offer method also we are having boolean. Okay. But here, So this add method basically, it will check this particular capacity restrictions. Okay, if the capacity is not available, it will throw an exception. It will throw an exception. But whereas this offer method, it is not going to be throw any exception. So this is important between this particular offer method as well as this particular add method here. Okay, now another method, remove method. So the name of the method itself, it is suggesting this particular method basically, it will try to remove the elements here. It will try to remove the element from this particular queue here. Now, so what we need to understand basically, so retrieve and remove the end of this particular queue. Okay, so whenever we are calling this particular remove method, it is going to be retrieve and remove the particular element here. And so this method differ from the pool. This method differ from the pool here, but if see, it is going to be through an exception if the queue is empty. Okay, so this is what we need to understand here. So offer method we observe the, and remove method also we observe here, and here, so what we can understand here, pool method. So what exactly pool method will do? Pool method also, it is going to be remove the element here, but if the element is not there, it will return the null. But whereas the remove method will throw an exception. Will throw an exception. And so what about this particular element here? What about this particular element? So element basically what is doing? Now element will throw an exception, but here it is going to be written again. Okay, it will return the element. If the element is not there, it will throw an exception. And whereas this particular peak method, this peak method also will load the element here, but if the element is not there, it will not throw any exception. Simply it will return the null. Simply it will return the null here. Okay, so remove method we observe the pool method, element, and the last method, so we need to understand the peak here. So carefully observe here, the queue interface, some of the methods are going to be through an exception and some of the methods are not going to be through an exception. Okay, this is what we need to understand here. So which methods are going to be through an exception? So remove method and element methods are going to be through an exception, whereas a pool method and peak methods, these methods are not going to be through an exception. Okay, so this is what we need to understand. Remove method will do the object from this particular queue, like remove the object from the queue, and whereas this particular pool method also will do the same, remove the object from the queue. But pool method will not throw an exception, whereas the remove method will throw an exception. And element and peak method. So this particular element method will throw an exception whenever we are trying to retrieve, whereas this particular peak method, the peak method, it is not going to be thrown any exception whenever we are trying to retrieve the value. Okay, so this is what we need to understand regarding this particular queue related interface here. And the last interface we need to understand, so something like DQ. Okay, so DQ. So queue basically what we observe here, first in, first out. First in, first out here. But whereas this particular DQ, okay, whereas this particular DQ, what exactly it will do? Along with this particular first in, first out, or it is going to be work with the last in, first out. Last in, first out here. So we'll see what are the methods we are having here. What are the methods we are having under this particular DQ? So far we discussed only Q. It is not a DQ. We discussed the Q related interface here. Okay. Now, so this DQ internally it is extending from this particular queue related interface. Internally it is extending from this particular interface here. Okay, whenever it is extending, again we observe here these methods we can copy. These methods, we can copy into this particular DQ. Okay, so along with this, what are the specific methods we are having? So that we need to understand now. That important method we need to understand here. Okay, so now, so this is the DQ method. Okay, so this is the DQ. Now what we can understand here, so DQ basically it will do the two operations. So first in first out, and at the same time last in first out also it will do the same operations, like from beginning to end it will do the same operation, like basically it will do the this is operation, and it will do the by directions operations here. Okay, so first in first out operation it will do, and last in first out also it will do. So mainly what we can understand here, so by directions operations are going to be work with this particular DQ, but whereas this particular Q only first in first out operations only it is going to be implemented here. So we'll see, so what exactly the DQ is interfaces we implemented. First we need to understand the methods here, so that we can easily understand the implementation easily here. Okay, so now focus on the DQ related methods. So what are the DQ interface related methods? So now if you observe carefully, add first method. What exactly the add first method is doing now? What exactly add first method is doing now? So to understand this particular method, now here you can see add the name of the method itself is suggesting we are going to insert the value. Okay, we are going to insert the value into this particular DQ, but here so here what we need to understand is it is going to throw an exception if there is no space. Getting the point? So same like a offer method. Okay, same like the offer method or add method. So in the queue interface, we observe the one method called add method here. If you go to this particular above, we are having add method. So what exactly it will do this? So this is basically if there is no space here, if there is no space, it will throw an exception. And at the same time, this add first also will do the same here. Okay, add first also will do the same. But add first, what is saying is whenever we want to insert the element into the first of the DQ here, first of the DQ, it will do the same here. Add last. Add last basically, if you want to add element to the last of the DQ, last of the DQ interface. So we can go for this particular add last method, but it will also do the same. It will throw an exception when there is no space here. Okay, offer first. So carefully observe offer first. So offer first basically what it will do, it will also add element. Okay, it will also add element here, but this particular method it is not going to be through any exception. It is not going to be through any exception. Simply it will return true or false value. So same it is applicable for the offer last. So here what we can understand here, these are the four methods. So these two methods basically it will try to add element to the first of the DQ, and the remaining two methods it will add last of the DQ. But one method will throw an exception, one method will not throw an exception. Okay, while inserting first element or the last element. So which methods are going to be through? Add first method, add last methods are going to be through an exception. So remove first. Remove first also will be the same. It will throw an exception. It will throw an exception. The remove last also. Okay, the remove last also will throw in a same exception here. Okay, remove last also it will throw an exception, whereas this particular pull first will not throw an exception. Okay, whereas this particular pool first will not throw an exception, and at the same time the pool last also it will not throw an exception. So now you can see adding 4 method and removing 4 methods. Adding we are having 4 method, 2 method will throw an exception, 2 method will not throw an exception, and at the same time, so 2 methods will remove successfully, but 2 method will throw an exception while removing if the respective values are not available. So now you can see get first method. Okay, get first. So the name of the method itself suggesting loading the first value, and at the same time loading a last value. Okay, and here so peak first method will not throw any exception, whereas a get first method will throw an exception. Okay, get first method will throw an exception. Now here you can see get first method will throw an exception, get last method will throw an exception, but whereas this particular peak first method will not throw an exception, and the peak last method, okay, will not throw any exception. So these are the different type of method we are having under this particular DQ. So now you can see remove the first occurrence. So the name of the method it is suggesting whenever we are providing this particular parameter, so first it will check if the value available first time, the first object it is going to be removed here. And so same way remove last occurrence. Given parameter value, so if you found the last occurrence here, it will try to remove the particular element in the last here. So now you can see add method which is coming from the where this add method we can understand which is coming from the queue interface as well as collection interface. So add method, offer method, remove method, pull method, and element method, peak method, so and add all method. So which is this add all coming from the way collection method. So push method. So these are the specific method. Okay, push and pop method. Getting the point? Push and pop method. So push method it will insert the value, whereas the pop method will load the value. So we'll see this. So remove method, contains method, size iterator. These are the we observe the some of them are coming from the collection interface, some of them are coming from the queue interface. So these are the specific method we observed under the DQ interface. So now you can see queue interface, these are the methods. Okay, DQ interface, these are the methods. And at the same way, navigable set, these are the methods. Okay, so sorted set, these are the methods. So set we don't have. Okay, set basically these are the default method we copied here, but set does not contain any abstract method. Whatever the method we have under the collection, all the methods are copied into the set interface. Okay, so up to today we discuss about the all the interfaces and the each and every method. So now finally we'll see the interfaces hierarchy. Finally we'll see this particular interface hierarchy. So this is we can understand the list interface, and this is we can understand the set interface, and this is we can understand the queue interface. So now list as of now it is not extending anything, and the set internally it is extending sorted set, and sorted set internally it is extending navigable set, and here the queue internally it is extending this particular DQ. So these are the interfaces hierarchy. Okay, so for whatever we discuss here, these are the interfaces hierarchy, and tomorrow we'll try to work on the implementation classes. So far we discuss only interfaces. So far we discuss only interfaces. We'll discuss about the implementation classes. So what exactly the implementation classes will do? Now those information we'll try to start from the tomorrow class onwards here. Okay. So any questions? Any questions or regarding our today's session? Okay. If you don't have anything, we'll continue tomorrow.
Sir,
Yes.
can we see with one small example, sir, all these methods?
Yeah, we are going to discuss one example one by one.
Okay.
We'll start first. We'll start the implementation classes, and we'll see the how the each and every method is implemented, so that we can easily understand the collection framework.
Okay. Thank you, sir.
Okay.